Just outside Shanghai, on the northeastern coast of China, lies one of the largest shipyards in the world. Here, thousands of engineers, technicians, and workers have taken on a colossal challenge: the construction of 9 of the largest container ships ever built simultaneously. This isn't just another industrial project. It's a test of human skill, engineering brilliance, and international collaboration. The project is led by the French shipping company CMA-CGM, one of the world's leaders in maritime trade. Each of these 9 ships will be able to carry 23,000 containers, transporting nearly 215,000 tons of goods per voyage. To put that into perspective, if all those containers were lined up end to end, they would stretch for 150 kilometers, long enough to cover the distance between 2 major cities. The first ship of this groundbreaking fleet has been named the Jacques, honoring the company's founder. And it's not just the size that makes these vessels extraordinary, it's the technology that powers them. A revolution at sea. At the heart of this new generation of ships lies a revolution in fuel. Liquefied natural gas, or LNG, stored at an icy -161 degrees Celsius. LNG burns far cleaner than traditional fuel oil, drastically cutting greenhouse gas emissions. Each vessel is equipped with the largest natural gas-powered engine ever built, towering nearly 20 meters high, about the size of a 6-story building. This engine turns a 10-meter-wide propeller. It's powerful enough to push a fully loaded ship weighing over 300,000 tons across the ocean. In many ways, these ships represent the future of global trade: bigger, cleaner, and more efficient. But building 9 of them in less than 2 years? That's where the real challenge begins. The mega shipyard, the shipyard on Changxing Island, near Shanghai, covers nearly 4 kilometers of coastline. With 3 enormous dry docks, it's one of the few places on Earth capable of handling multiple megaship projects at the same time. Inside this floating city of industry, over 6,000 specialists from across the world are working day and night. To stay on schedule, the ships are built like giant Lego sets. Each ship is divided into thousands of blocks, massive steel sections weighing hundreds of tons. These blocks are prefabricated in warehouses, complete with piping, wiring, and fittings already installed. Then colossal cranes, capable of lifting 600 tons, move them into position. Piece by piece, the skeleton of the ship rises from the dry dock until the whole takes shape. The dimensions are staggering: 400 meters long, equal to 4 soccer fields, 61 meters wide, 78 meters high, taller than the Statue of Liberty. A single ship weighs 70,000 tons before any cargo is even added. Precision is critical. Every block, every weld, and every connection must be flawless. At sea, even the smallest weakness could spell disaster. LNG tank. A giant freezer at sea, one of the most complex parts of the ship, is the LNG tank, the vessel's energy reservoir. Developed by the French company GTT, it's the largest tank of its kind ever built, capable of holding 18,000 cubic meters of liquefied gas. That's as much volume as 6 Olympic swimming pools. The tank must keep the gas chilled below -160 degrees Celsius for weeks at a time, even in the middle of the ocean. To achieve this, engineers install layer after layer of specialized insulation, 27 centimeters thick, to create a kind of enormous, high-tech freezer. At the heart of the tank sits the gas mast, a 25-ton steel tower equipped with pumps that feed LNG to the engine. It must withstand freezing temperatures, powerful waves, and extreme pressure without moving even a millimeter. Installing this mast is a delicate process requiring absolute precision, as it is lowered centimeter by centimeter into the tank by cranes. After months of insulation, welding, and testing, the LNG tank is sealed shut, airtight, and ready for decades of service. The beating heart. The engine, meanwhile, in another part of the shipyard, the ship's giant engines are being assembled. Each one measures 24 meters long, 18 meters high, and weighs 2,000 tons. It generates an astonishing 85,000 horsepower. Before installation, every engine is pushed to the limit, tested at 110% capacity to ensure it can handle extreme conditions. Repairing such a machine at sea would be nearly impossible, so reliability is everything. The engine's core component, the crankshaft, weighs over 200 tons. With the help of 140-wheeled transporters, these colossal parts are carefully moved across the shipyard at a walking pace to be lowered into the hull. Piece by piece, the engine is reassembled inside the ship crankshaft, pistons, cylinders, and finally, the engine cover. Once complete, it becomes the beating heart of the vessel. The propeller precision in motion at the stern of the ship, another marvel of engineering, is installed. The 92-ton propeller, cast in a single piece of steel, it measures 10 meters across. Connecting the propeller to the engine requires absolute perfection. Any misalignment could cause catastrophic failure. Engineers use a thin layer of dye, known as methylene blue, to test the fit between the propeller and its shaft. The tiniest imperfection is revealed, corrected, and retested until the parts are seamlessly aligned. Only then is the propeller locked into place with hydraulic pressure. Finishing touches beyond engines and tanks, every detail of the ship requires attention. The hull, which covers nearly 1 million square meters, must be coated with specialized paints to prevent corrosion and marine growth. Without this protection, barnacles and algae could slow the ship, increasing fuel consumption. Nearly 1 million liters of paint are used per vessel, applied in multiple layers, inspected and reapplied until the surface is flawless. Inside, the cargo holds are designed to carry anything the modern world demands: electronics, raw materials, vehicles, and even fresh produce. Refrigerated containers plug directly into the ship's power supply to keep fruit and vegetables fresh for weeks. When fully loaded, these ships resemble floating skyscrapers, carrying the equivalent of 1 billion smartphones at a time. The bridge command center of the seas, at the top of the vessel, lies the bridge of the ship's brain. Here, navigation systems, cameras, and sensors give the captain and crew full control over the 400-meter giant. Special Smart Eyes cameras provide a 360-degree view of the vessel, allowing the captain to maneuver safely into port, even though the bow and stern can't be seen at the same time. Docking is done at just 0.4 kilometers per hour, with pinpoint precision. Sea trials in the future. After nearly 2 years of relentless work, the first ship, the Jacques, is launched. Over the next 15 days, it undergoes sea trials testing speed, maneuverability, the anchor system, and of course, the massive LNG engine. Every system is pushed to its limits, from the 370-ton anchor chain to the navigation electronics. The ship passes with flying colors, ready to join the global fleet. One by one, the other 8 ships follow, delivered over the following months. Together, they mark a turning point in maritime history, proving that it's possible to build bigger ships while still reducing environmental impact. Why it matters today? Nearly 90% of global trade moves by sea. More than 100,000 cargo ships crisscross the oceans every day, delivering everything from food to electronics. The challenge of the 21st century is not just to keep up with demand, but to do so sustainably. By running on LNG, these 9 new CMA-CGM vessels cut emissions dramatically, offering a glimpse of a cleaner future for shipping, but the journey isn't over. Engineers are already working on the next step: ships that eliminates co-emissions entirely. For now, these 9 steel giants stand as a testament to human ingenuity, a blend of advanced engineering, global teamwork, and relentless determination. Built in record time, they are more than just cargo carriers. They are symbols of progress, charting the course for the future of maritime transportation.